Here we are with the Week 10 video. And remember, it's good to watch this video compared against your own test. Good to watch this video and compare it against past tests. You're going to see these concepts keep coming up back and forth, back and forth. So let's get started. Problems number 1 and 3, numbers 1 and 3, pretty straightforward problems. 8 times 3 is 24. Since we have one negative and one positive, our answer is negative 24. Rule to remember: when you multiply a positive number times a negative number, you will always get a negative number because you have different signs. So different signs will always result in a negative number. Different signs. Now remember, this is only multiplication and division. You cannot use this rule when you add or subtract. So different signs, multiplication and division, will always be a negative answer. Number 3, let's scroll down, give ourselves a little room to work. Number 3, we have a negative number divided by a negative number. So 27 divided by 9 is 3. And since here we have a negative divided by a negative, we're going to get a positive answer. Same signs, and again, this is only for multiplication division. Same signs will always be a positive answer. So we can go ahead and use these facts as we move into problem 2. In problem 2, part A, first off, let's look at the rule for this. You have to know the rule. The rule is x times y equals z. We don't know what x is, we don't know what y is, but we do know x times y is equal to z. So, in part A, we look at this. We look at the answer. The answer is opposite of z. Now, we're only given these 6 terms that we can use. Either x, y, z, or opposite of x, opposite of y, opposite of z. Here we're getting opposite of z. Opposite of z is telling us the two have to have different signs. The only way to get a positive answer like B is same signs, and the only way to get a negative answer like A is different signs, which means we could either have x times the opposite of y, or for this one, we could have the opposite of x times y. That would also give us opposite of z. As long as the signs are different, negative sign, positive sign, negative sign, as long as the signs are different, answer will be negative. On B, since this is positive y, we know that we're dealing with same signs. Now, the confusion that a lot of students had on B was they didn't know whether to put the x on top or the z on top. The answer was y. They didn't know, do I put the x or the z on top? The missing things. Unlike A, which is multiplication, you could have x times opposite of y, or you could have had opposite y times x. In division, you cannot change the order. Division is not commutative. And the example we did in class was, think about the problem 2 times 5 equals 10. That can be changed into one of two division problems. Either 10 divided by 2 equals 5, or 10 divided by 5 equals 2. But in either case, that was bad grammar, don't tell Miss Silvani on me. In either case, it has to be the 10 on the top. It has to be this answer that we have divided by one of these gives us the other one. So that leads us to our answer on B. It is either z divided by x, same signs to get positive answer, or it's the opposite of z divided by the opposite of x, to get positive y. Have to be same signs. Moving down, C and D. So this is different signs. Has to be different signs to get a negative. We already have a z that's positive, so our missing part has to be opposite of y. On D, it's a positive answer, so it needs same signs. And since we already have a negative, the missing part has to be positive. Oh, excuse me. Since we already have a negative, the missing part has to be negative. I misspoke. Has to be same signs. So since this is already negative, that also has to be negative. Okay, if there's anything there you need to review, you need to hear me talk about that again, just go ahead and play back the video. If not, let's move on to 4, 5, and 6. In 4 and 5, the rule was use the tiles to model and solve. Some of you might be looking at your paper thinking, wait a minute, I got the right answer. In this case, the right answer is 3. I got the right answer. How come I didn't get full credit? Well, if you didn't model it, you didn't get full credit. So the model on this one would look like -4 plus +7. I like to do mine first number, second number. If you did it like the dance where you put them up and down, that's fine. And then we look at how many of these are paired up. In this case, there are 4 0 pairs. What's left are these 3, and they create our answer of 3. Number 5, 5, we talked about this idea that we don't solve subtraction problems here. We add the opposite. So instead of 3 minus 8, we can't change the 3. That's what we're starting with. Can't change what you start with. But we can go ahead and add -8. And then we do the same thing. Here are our 3 positives. Here are our 8 negatives. 1, 2, 3, 4, 5, 6, 7, and 8. Now you should be getting to the point where you look at this even before you draw it out and you say, oh, it's got to be a negative answer because there are more negatives. When I 0 pair these out, when I get these 3 0 pairs, I'm going to be left with these 5 negatives, and my answer to this is -5. On to 6. So you have 4 different problems, sub-problems in number 6. You're supposed to find a value that makes them true. So here we have -2.3, and we're adding something to get a positive number. Well, we could add 3. That would give us a positive. We could add 4. We could add 5. We could add 6. We could even add 2.4. Anything bigger than the 2.3 negatives. We need any number that's greater than 2.3. Because if we have a number greater than 2.3, then part of these will cancel out all of those, and they'll leave some positives left over. Letter B, we have 8. We need to add to it to make a negative number. Well, you could add -9. You could add -10. You could add -11. You could actually add -8.1. We basically need any number that is less than -8. Now this is one I want to point out. I want to just do the quick number line thing here because you might say, well, wait a second. You got -9, -10, -11. You mean things bigger than -8. No, remember, if you put -8 on a number line and you're doing things getting smaller, that's where the -10, -11, the -9, these are all things smaller than -8. Things bigger than -8 are things like -7 and -6. So we need things that are less than -8, including -8.1. Letter C. We have something, we're going to subtract 3.5, and we need to get a negative, which means we need to be starting with less than 3.5 so that when we take 3.5 away, there's nothing left over, and that's what moves us into the idea of negatives. So if you started with 2, for example, and you took away 3.5, you're taking away more than what you have. You would have negative 1 1/2. If you had 3 and took away 3.5, you'd have negative 1/2 because you took away everything you had, all 3, plus another half. 1, any of these numbers work. In fact, as long as you don't get up to things greater than 3.5. If you put 4, well, 4 take away 3.5, that would give you positive 1/2. That would be a positive. So in this case, we need a number that is less than 3.5. So that when we take 3.5 away, we've taken all of this away, and that's what gets us into the negatives. All right, last one in this section. Negative 11 plus what makes 0? It's positive 11. You add opposites to equal 0. Now you might say, wait a minute, last week I tried that and it didn't work. That's true because last week it was a subtraction problem. If you had negative 11 minus what to equal 0, well, when you're subtracting, you have to take away the same thing that you have. So if it's subtraction, it's the number minus itself to make 0. But if it's addition, it's the number plus its opposite to get 0. All right, let's move to the next page. Distance coordinate plane problems. Gosh, you got to love these. Distance coordinate plane problems. Nothing more exciting than that. So what's the distance between negative 4, 2 and 6, 2? And in class, we talked about going ahead, drawing ourselves a coordinate grid set of lines. We said we didn't have to make these super fancy. Didn't need to break out a ruler. Needed to be able to label the x and the y. And then we need to be able to go through and decide, all right, this is a negative 4. Now, this is the x. This is the y. So we need to be able to get to negative 4 on the x. And I didn't measure those perfectly. I just counted out to negative 4. And I need to get up to 2 on the y. There's my 2. That takes care of the first point. Second point, also x, then y. So I have 6. 1, 2, 3, 4, 5, 6 on the x. And again, 2 on the y. Now I'm going to figure out where those points would be. So here is the point. Negative 4, 2. Negative 4 on the x, 2 on the y. Here is the point. 6, 2. 6 on the x, 2 on the y. How far is it from here to here? Well, that's going to be the 6 spaces. You can see those 6 spaces, 1, 2, 3, 4, 5, 6, to get us back to that point on the y line. How far is it from here to here? Well, that's going to be 4 spaces, or 4 units, however you wanted to say it. 4 spaces, 4 units. It's going to be a value of 4. This should look familiar. Absolute value. So really what we're doing is we're saying take the absolute value of negative 4, add it to the absolute value of 6 to get the distance. And 4 plus 6 makes 10. And you can actually see 4 and 6 more right there gives you 10. So our answer is 10 units, or 10 spaces. Number 8, same idea. This time we just get a coordinate grid map to use. So Maria made a map of her neighborhood. Here, each unit represents a mile. So when we do our answers on this one, we're going to show our answers in miles. So the first one we have, what's the distance from the park? Find the park to the school. There's the school. Well, it's 1, 2, 3, 4, 5, 6, and don't forget to take that 7th step. 1, 2, 3, 4, 5, 6, 7. 7 units, and in this case, every unit is a mile, so it's going to be 7 miles. What about the distance from Maria's house to the school? Well, here's Maria's house. So she's going to go 1, 2, 3, 4, 5, 6, 7. And again, don't forget that last one right there, 8. She's going to go 8 miles to get from her house to the school. Maybe she rides her bike every day. She's building muscles. All right, on to number 9. Use, and we've talked about writing these out each time, use either is less than or is greater than to compare each of these. A, -7 compared to the absolute value of -4. We've spoken about the fact that anytime you see these absolute values, you should put the actual value down. You could even go through the problem and you could simplify all the things that need simplifying. So this one needs simplifying to 9. This needs simplifying also to 9. My pen touched there. I didn't want you to think we had a negative. So now we're ready to go through and compare. Well, we know that -7 is less than +4. And we know that -4 is greater than -6. And finally, we know that 9 is equal to 9. Number 10. We are being asked to list these cities from coldest to warmest. Well, the coldest city on the list would be Juneau, right here, -9. That's the coldest temperature. If you did it by writing Juneau down, that's fine. If you had the 5 cities in the right order, you got credit for that. Next, Buffalo at -7 degrees, followed by Anchorage at -6 degrees. Now, Anchorage and Juneau, those are both in Alaska. Might not surprise you that they're really cold. Buffalo is actually in New York, so the Buffalo's colder than a city in Alaska. I guess that's why we live in California. Albany at 5 degrees, and then Reno at a super warm 12 degrees. So there are your 5 temperatures from least to greatest, anytime you're doing coldest to warmest. A mathematician would say you're listing things from least to greatest. And by the way, you did really well on that last problem, on number 10. A lot of correct answers. All right. We're in what they call the clubhouse turn in the field of horse racing. We're down to the end here. So on 11, we should do the same thing again that we talked about last time. We should go through and simplify. This simplifies to 5, to 6, to 12. This one, a little trickier. The absolute value of 5 is 5, so the opposite of that is -5. And now we're ready to compare. 3 is less than 5, 6 less than 8, 12 greater than -5, and -5 is equal to -5. All right, definition of absolute value. So the definition of absolute value is right here. It is the distance between a number and 0 on a number line. Now, some of you wrote things like absolute value is something that's always positive, or absolute value is the distance on a number line, or absolute value is the distance to 0. Distance has to be from something to something. So you can't just say the distance to 0. It has to be something like the distance between a number to 0, or between a number and 0. As far as a diagram goes, the easiest diagram to think of is the number line diagram. Here is our lucky 0. That's the center of the number line, kind of like the middle of a teeter-totter. And then we have numbers getting greater, moving away from 0 to the right. Numbers getting smaller, moving away from 0 to the left. And the idea of absolute value is the difference between a number like -3 and 0. You can see that that is 3 spaces. So that would be a diagram. Remember, diagrams, anytime you see them say we're looking for a diagram, they are talking about some kind of a picture. A diagram could be a drawing. So pictures, drawings, illustrations, things that catch your eye with the picture, not just some numbers or just some words. So this first one shows the absolute value of -3. It shows that the absolute value of -3 is 3. And then to really complete it, we want to do the positive analog to that. We want to show that also the absolute value of 3 is 3. We want to get away from the idea that absolute value is just something that turns negative things into positive things. All right, so there's the test for you. Let's go down. We'll just do that last one. This threw a few people off, and it doesn't count for anything, so I chose not to give any more explanation. When you see something like this, what they're really asking you is, which one of these is the same? Which one of these gives you the same answer? And the one that gives you the same answer is A. A -6 times a -8, same signs. Anytime you multiply things with same signs, the answer is positive. Here's the only other same sign problem. +12 times +4. These others all have, let me do it with a highlighter. These others all have one negative and one positive, so they cannot possibly give the same answer. They each give a negative answer because their signs are different. In this case, it happens to be the opposite of this answer. There are -48s on all of those, so your correct answer was A. All right, so there you go. Week 10 test. You've got time to review this before you have the Week 11 test. You're going to have some of those same concepts. The ones that you really want to focus in on would be anything that is an A or a B. So, for example, right here, that's going to have a similar kind of problem. I would really focus in on this one. That one's huge because that's the one where you have to both keep track of the fact that you have to worry about the signs, but you also have to worry about the order. This is also going to come up again. Oh, I'm having trouble getting that to stay on the screen. This is also going to come up again. This is a B problem. So if you didn't diagram it out the last time, you didn't use the tiles to model and solve, make sure you use them this time. If you had that problem with not following this, be sure you take a look. If it's addition, you're going to be adding opposites. If it's subtraction, you're going to be subtracting the same value. This coordinate plane distance, also a B problem. So you're going to want to make sure you're on top of that. All the rest of the problems, you don't have to treat these like, oh, well, they're C problems. I'll never have to worry about those again. You do have to worry about them for two reasons. One, you just have to have the math knowledge. Two, if you want to work on your grade, the thing to do is to go back, study these that you didn't do well on when we took the regular tests, and then do an intervention test. And you'll have to see me about planning that intervention test. All right. As always, if you have questions, be sure you bring them to class. And thank you for watching the video. Share it with your friends. Tell them how cool it was.